Okay, so this is Unit 1, Section 1.5, and we're going to introduce similar polygons. So as we're looking at our triangle similarity unit, this is finally the first time that this word similarity, similar, is coming into play. So what we're going to be able to do by the end of this section is to be able to explain that figures are similar by the definition of similarity. All pairs of corresponding angles are congruent, and all pairs of corresponding sides are proportional. So this word is why we practice proportions and all the solving that led up to it. So as we're practicing this, we're kind of looking at more explaining and verifying than any calculations today. Notice that we have our first unit quiz, which will solve or cover everything up into that Unit 1 quiz. So if you have questions, we want to make sure that we're addressing them before we get ready to review and practice and take our Unit 1 quiz. All right, so with 1.5, we're going to start looking at similarity statements. So if I want to say something is similar to something else, it's kind of like my pet peeve when somebody says like, oh my gosh, I have that exact same shirt. And I'm like, no, you don't. You probably have one that's similar to it. Like we might have different sizes, we might have different colors of it, or your wording might be different. We don't have the same shirt. We have similar shirts. But that's probably me just being a little too teachy. The symbol that we use for similar is just one little squiggle, kind of like this. So the symbol for similar, we're going to say this object is similar to this object. So we read it as similar to. A valid similarity statement must match corresponding angles and sides. So if I want to say that this triangle is similar to this triangle, we need to make sure that everything's corresponding. And so in Integrated 1, we talked about corresponding angles and sides when we talked about triangles being congruent. When we do corresponding parts here, corresponding means they're in the same position. So we talked about corresponding angles when we did lines cut by a transversal, that this would be in the same position as this angle. These are corresponding angles. They're in the same position on this intersection and this intersection. They're both kind of in that left kind of upper side there. Same thing here. If I write a triangle ABC, I can name this one however I want. Is similar to, so I'm going to use my new symbol there, triangle. I need to match up who's in the same position as A, B, and C, matching up those corresponding angles and sides. So angle A has one tick mark, similar as angle D. So I'm going to match it up. It corresponds. A corresponds to D. B has two marks here on its angle, same as E. So I'm going to match it up to E, which follows F has to be matched up to C. A, B, C, we can label any way we want. Slow down and label carefully the second triangle. This is called a similarity statement, where I'm relating one triangle similar to another triangle. So in this example, we're just practicing writing different similarity statements because there's multiple ways that I can name each part. So if I look at the very first one here, let me get my pen back. And I just don't have a triangle here, but I have a quadrilateral. It doesn't matter how I name that first one. So I might name it KLMN. Okay, as long as I don't cross through the middle, this would not be a proper way of naming it. So KLNM wouldn't be proper, but I can start and go left, I can start and go right, as long as I go in order around. And because this is a similarity statement, I'm going to use that similar symbol. KLMN is similar to, K is in the same position as P, L is in the same position as Q, M is in the same position as R, which means S must be in the same position as N. So, based on these two, this would be just one of the similarity statements. Maybe I would have started with M on the other one and gone MLKN. This would be another way to name that first statement. And I could say it's similar to, and make another statement matching up M with R, Q, P, and S. This is another valid similarity statement that is correct and matches up those two figures. And maybe the last one we would have started at L and said L, M, N, K. Okay, so even if I didn't have the other picture, if I already had one of the other statements, I know L goes with Q, I know M goes with R, and I could use this knowing that it's already set up correctly to name another similarity statement. So if we were already given triangle ABC is similar to triangle DEF, if this is already known, I could say triangle CBA and go the other direction. And I would know that this has to match up to EFD because it has to match up those corresponding parts. It's really more of like a matching game today than a calculation. All right, in addition to kind of setting up this similarity statement, there's parts that we have on these similar figures. So if I want to say these two objects are similar, this is going to be polygons that have the same shape but different sizes. So these figures were the same shape, but they're different sizes, so they're not the exact same. That's why they're similar to each other. Same with these two. These are the same shape, they're the same triangle, but they're not the same size. This one's larger, this one's smaller. So if I want to say two figures are similar, I know that they have the same shape, but they're different sizes. And there's two rules to guarantee similar objects. I can show that polygons are similar if all the corresponding angle pairs, so all the pairs of corresponding angles are congruent. And so the symbol for congruent here, I'm going to use. So similar objects are same shapes, different sizes. Congruent means they are the exact same. So here's our first rule. Our second rule is not only do we have to have all the pairs of corresponding angles congruent, we need all pairs of corresponding sides to be proportional. So there's two rules to get something that is the same shape and the same size, different sizes, excuse me. We need all the pairs to be congruent and all the sides to be proportional. So what that tells us is that, do you see our congruent marks? We have the angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. But 8 is not the same as 12. Those are not the same. So the sides are proportional. And what that means is what we were practicing with before. 8 goes with 12, but not as an equal sign. 10 goes with 15, but do you see that I'm setting them up as ratios? 14 does go with 21. And if I checked this by dividing or by cross multiplying any of these pairs, they would all be the same. 8 divided by 12 is 0.666666. 10 divided by 15, 0.666666. 14 divided by 21, 0.666666. They're all proportional. That's what guarantees us the similar pair polygons. Angles are congruent, sides are proportional. All right, so this is just practicing matching up those parts. Given a similarity statement, can we match the congruent angles and proportional sides? So if I'm matching up the angles, I have angle J that has to be congruent to angle P. And notice I'm using the similarity statement because this has been turned. Angle K, the second letter, goes with M. So these are congruent. The figures are similar, angles are congruent. And the last one, angle L, congruent to angle N. So I've listed my 3 pairs of congruent angles, and I can mark it on my picture. J goes with P using my little arc. I'll do 2 with K and M, and 3 with L here and N here. The sides are proportional. So if I look at 2 letters here, J to K, it has to go with 2 letters over here, P to M. And it's proportional to maybe the next 2 letters, K to L, next 2 letters, M to N, which would lead us to the 3rd letter, L to J, for this 3rd side, and N to P, matching up those 3rd sides. So again, this is all, there's no sides here, there's no angle measurements, but we know this has to be true because they're already telling us that these are similar objects. Let's look at another one. All right, so we know that triangle XYZ is similar to triangle RYS. All right, so what pairs of matching angles do we have? We have angle X here goes with angle R here. It's congruent. Those are the exact same measure angles. Angle Y is the same as itself. It's reflexive. That's angle Y there. Angle Z must then go with angle S. So again, we can use the picture, but I find it easier to match up when they give me a similarity statement. XYZ, RYS. I kept the order the same. So then when I'm looking at the sides, I have XY goes with, so if this is XY, it goes with RY. And it's proportional to YZ, this whole side of the other triangle, or of the first triangle, and YS on the second smaller triangle. That looks like a 5. Let me try again. YS. And then the third sides, XZ and RS. I just like looking at this and going XY, RY, YZ, YS. And then I wrap it around to finish it off. ZX, RY, or I'm sorry, SR. So I'm lining up those pieces each time. And again, the picture is helpful, but this contains all the information that we need to get our proportional sides or angles congruent. On 3, now we have a 4-sided object. So now I'm going to have 4 angles that are congruent to another set of 4 angles. So maybe we see a pattern already happening and we can do this faster just setting up J, K, L, M, straight from here. And that has to be congruent to the other angles in the same order. The order matters. Q, R, S, P. And I can quickly do that without even looking at the pictures because this has been rotated. It looks like if I just went kind of on how it's oriented, J would go with S. But there's been a reflection or a turn here that's kind of made the picture a little bit more complicated. That's why we're given the similarity statement. The sides, now I'm going to pick 2 sides here, J to K. And I'm going to go in order. J to K is going to go with QR. And then I move it. Okay, so now J to K moves to KL, KL or QR moves to RS. And move it again. LM goes with SP. And the last one we always wrap back around. MJ to PQ. So what this is telling us is it's Similar objects give us congruent angles and proportional sides. So right now, we're taking the similarity statement and we're verifying. We're just writing things out that says, okay, if that's true, then so is this. The rest of this unit is going to be taking the information the other way and saying, well, do we have this? Is this all true? Then we can go backwards and verify that it's actually similar objects. So right now we're saying, given similar, what else do we know? The question after our quiz is going to change and say, okay, can we show that these are similar, or are these similar? And we have to use the angles and sides to justify the next statement. If you have any questions about setting these up, let me know, and have a good one.